Hello, fellow Scratchers! Yes, oh yes, moving platforms! I'm so very excited because, well, this episode is pretty much the whole reason that I began the Classic Platformer series. Yes, I am Griffpatch, and today we are adding moving platforms. Woohoo! These platforms can come in all shapes and sizes, and can have simple or complex movement patterns. We'll also be covering the tricky issue of collision avoidance and the unavoidable and very sad squishing of cats. Yes, it's all here, so gosh, what are we waiting for? Let's get scratching. As we begin, make sure to save a copy of your episode 7 projects, for this is episode 8. Now, since we are going to want to add a moving platform right here on the very first scene of the level, I'm going to click into the level Sprite's costume editor and make some space by deleting the central diamond shape. Cool. Now, let's create a new sprite to represent the moving platforms. I'm going to name it Platform for short. Next, draw a simple rectangle shape. This will be my moving platform, but don't worry, it can be any shape or colour you want. You should play around with some of these for some fun. But now, we can drag the platform on the stage to a good starting position. I'll pop it down here in reach of Scratchy. Okay, that's a good start. If I run the project, the moving platform is visible, but it is far from solid. We can run right through it. This is the first thing we should solve. As you might suspect, it will be really easy. Click into the player sprite and find the Check Touching Solid custom block. You remember when I made you create this block, and you probably thought, gosh, why go to all the effort of creating this only to do a touching sprite? We could have done this without it. Well, this is where we get the payoff. Where we originally had touching level, now we bring in an OR and switch it to have 2 touching blocks. The second one can become the new platform sprite. So what have we done here? Yes, everywhere in our code that uses the Check Touching Solid, and that's quite a lot of places now, every one of them will now also count platforms as solid too. Oh yeah, now that saved us a whole lot of time. Let's test it out. Walk over and jump on the platform. Yeah, look at that. The platform is indeed fully solid. That's great. Just as solid as the level itself. Well, next up, walk onto the next scene. Ah, the platform is here too, and it's just as solid as it was on scene 1. So we need to tell the platform which scene it belongs to. Click into the platform sprite. We have a nice event for changes of scene. So bring in a When I Receive event block, and the event we'll use is, change scene. Great. The event only gets triggered when the scene is changed. Not every frame, which is very useful to remember. Now, to ensure the platform does not appear on every scene, we'll hide the sprite. Then, if scene hash equals 1, our first scene, then show. That's about as simple as it gets, right? But luckily, this works just fine. You can imagine we can add as many ifs here as needed to define moving platforms on lots of scenes. But enough of that. Let's get that platform moving. Make a new custom block. We'll name it Animate Platform. I use the word animate because it reminds me that this is a long-running operation, and we should therefore not be ticking the run without screen refresh block. It'll be clear why shortly. So drop a copy of this new block into the change scene if block after we show the platform. Okay, a little bit of teaching for you now. We will shortly be adding scripts into the animate block that will move the platform up and down in a forever loop. So the question is, if we are looping it forever, what will happen if the player changes scene? Will the script keep running? The answer is no. And why not? Well, event receivers, like this one, have an interesting property in Scratch, that when they get broadcast again, while a previous one is still running, the previous one gets stopped right away before the new one begins running in its place. So, when we move to scene 2, the animate platform script gets stopped, and the platform should hide. Okay, lesson over. Let's make the animation. As long as your project is stopped when you drag out your go-to XY block, it will be automatically set to the position of the sprite on the stage as it is right now. That's useful. Now drag the platform to its next position, up here. Now let's get a glide block. Cool, again, it's all set correctly. I can test the project to check. Now it glides right up there. But it's a tad too fast. I'll change the glide speed to 2 seconds. Yeah, that's much better. Next, to glide it back down to the start, drag in a new glide block. Oh wow, it's set it to the original position. I was expecting the new position, but I guess this is because the project is still running. It must remember the first position it was in. Well, just make sure that the x and y of the glide are the same as the x and y of the original go-to-xy, okay? And set the glide speed to 2 seconds, as before. Running that gives us a nice up and down motion. So, to keep the motion going, we can surround the glides with a forever loop, like this. Now, one more thing that can make this look even better is to pause the platform at the top and bottom with a wait block. For 1 second will do. Okay, this is looking perfect. I'm all ready to give this a try. But what will happen if we get on board? Oops! Wow, this wasn't so great. The lift was able to move right through us. How did this happen? Well, this has to do with how, and more importantly, when our sprite collisions are detected and resolved. At the beginning of every game frame, we assume the player is not colliding. That is, not overlapping anything solid. Next, we move the player, check for collisions, and then move them back out of any collisions again. Now, what has changed here is that the platform scripts have now become the first thing to run in our game frame. How do I know it runs first? Well, that's down to how Scratch operates. The first thing to run is any script that is already running from the last frame, like a forever loop. We have our main game loop, and we have the platform forever loop. But look, the game loop broadcasts these events. So these events get ready to run as soon as possible, but not before this platform forever loop gets to run, because it was already running from last frame. And so, we know that the platformer will always get in before the other broadcast receivers. Right then, so the first thing to move in the game frame is the platform. Boop! But now look, that means we are beginning the player's scripts now only to find that they are colliding. This is not a good state to be in, as it is known as the stuck state in our game, and it becomes impossible to move. Now, why isn't the level turning red then, to show that we are stuck? Well, in the player sprite, find a when I receive tick player. Look, the switch background that we put in here is only looking for touching level, not touching platform. That was my bad. We should have really used our custom touching solid block for this too, shouldn't we? Anyhow, what we need to do for starters is now realise that we may be stuck in a level even as this event receiver begins to run. Tell you what, create a new custom block, naming it Moved by Moving Platform. And yes, we run without screen refresh this time. We'll use it first thing as the tick player script begins to run. I'll just move it into some space. To decide if we are indeed colliding, use the check touching solid block and check if touching is greater than 0. If it is, then we have most likely got trapped in a moving platform, and for now the quickest way out would be to use our existing Fix Collisions in Direction block, setting the direction to 0 to push the player up out of the collision. Okay, cool. So let's see what effect this has on the moving platform, shall we? Just getting ready to jump on top. And yes, look at that. We are going up. This is awesome. The platform feels super solid and is working surprisingly well. In fact, if you were careful with your level design, you might even be content with this just as it is, because it looks great. So well, are there any problems? Yeah, there are. Let me just walk under the lift. Okay, this isn't going to be pretty. And did you see what I saw? Scratchy miraculously avoided certain death by teleporting on top of the lift. That's crazy! But also expected. The fix collision in direction script we used was, after all, not designed for resolving collisions with moving platforms. And sadly, there's worse to come. Let's switch the direction of the animating platform. Click into the platform sprite. I'll duplicate the animate script so we can keep a copy. Now, let's quickly set the start position. And matching end glide position. And then fill in a new X position for where the platform will glide across to. Okay, running that now, let's see how this affects the game. If I jump on the platform, oh wow, it's hard to stay on. But wait, why is that? Well, it's because although the platform is moving left and right, unlike the up and down platform, it's not pushing me. And it's not pushing me because it's not colliding with me. No, it's just slipping by under my feet. So there's obviously another mechanic missing here, and that is floor friction. We need the very fact that I'm standing on this platform to mean that my player is moved along with it. The problem is, to do that, we need to know how far the platform has moved by each frame. And look, we are using a glide, so how much is it moved by? Well, let's work it out. Bring in a new WhenIReceive block. And we'll make a new event named tick platforms. Now, just like all the other tick events, as I described earlier, this too will run after the animate block, which is in a forever loop. So, by the time this runs each game frame, the platform will already have glided along by a small amount. Well, perhaps we can measure how much it has moved. Make a new custom block named tick, and add a numeric input of new x and another named new y. Check the run without screen refresh. Great. This new block will run under the new event, and we can pass in the new position of the platform, that is, position x and position y. Remember that the glide has already had its chance to move the platform, so this is the new position. But where was the platform last frame? We don't know, do we? Make two new variables, last x for this sprite only, and last y for this sprite only. Then, after the tick block has finished running, we set last x to position x, and then do the same for last y to position y. This means the next time this event gets broadcast, we will know where it was last frame. And the great thing about that is, we will be able to calculate how far it has moved. We can test this using a say block and a subtract. And we say new x subtract last x. Yep, that gives us the difference between the two x positions. Run that now. What? Oh, sorry, what a scatterbrain. We haven't yet broadcast the tick platform event. Click into the player sprite and find the WhenIReceive game loop script. We broadcast tick platforms and pop it after the first broadcast. Aha! We have something showing up now. Do you understand what we are seeing? The platform is telling us how many pixels it has moved in the game frame to get to where it is now. Notice when it stops, the number changes to a 0, because it's not moving. I think that's really cool, what with the fact we are using glides and all, and I'm certain that this will help us move the cat on the platform. So, back in the platform sprite. Move the say block out of the way now. Bring in an if-else. What we need to know next is whether the cat is even touching this platform or not. If touching player. Then, for now, say the speed again. Else, say nothing. That seemed like a good plan, but sadly this doesn't work. And why? Because the platform is simply never in contact with the player. As we said before, the platform is sliding along peacefully under our feet. To really know it's touching, we should move the platform up a little tiny bit before doing our touching check. Put another if-else block above the first, and check whether the new position is above the last one. In this case, the platform is moving upwards. This is the easiest case because, as such, we can just move the platform up a tiny bit more, change Y by 1, and it's bound to be touching the player's feet. But what if the platform is moving down, and therefore away from the player? That makes it a little bit more problematic because even if we move up a little bit, it could be far from the player's feet. But luckily, because we know the previous position of the platform, we can just put it back up there, and then look above that position instead. And then once more we will be able to locate a collision or not. We are not quite there yet though, as if you run that you can see that the lift is trying to drift away. That's because all the moving of the platforms has taken it off course of its original glide. We must restore its position after all the checks are done. Use a go-to and drop in the new X and new Y. That's where it's supposed to be. Run the project again. I'm feeling really good about this. I just need to get on the platform. It's harder than it looks. Yes! Brilliant. Now we can see the speed of the platform, but only when we stand on it. The obvious next step is to get the player to move along with said platform. Keep the first say block handy, but discard the empty one. We're all done with that. Now for flexibility, we are going to use some global variables to record the required movement of the player. Make two variables, platform dx for all sprites, and platform dy for all sprites. Now set platform dx to the new x, subtract last x from the say block. That now records the left and right movement. But platforms can also go up and down, so we also set platform dy to new y, subtract last y. So if we run the project now, and I climb on the platform, you will see platform dx changing value. But when we jump off mid-flight, you'll notice that platform dx does not reset to 0 or empty value, but stays set. That will cause us some confusion if left like that. But I'm not going to set them to 0 in the else here as you might have expected, because in the long run we will hope to have more than one moving platform on a scene. And if that is the case, then even if we are standing on one platform, the other platform would then set the variable to blank, completely messing up our code. So instead, click into the player sprite, and we want this tick first script. This runs before the tick platforms, so in here we'll set platform dx to the empty value and do the same for platform dy. Great. So smash that green flag and we should be able to confirm that the platform values are now only set when we are indeed standing on the moving platform. Excellent. We are really getting somewhere now. Find the custom block we created earlier today, moved by moving platform. And now, before we check for collisions, let's move the player. We need a change x by and a change y by block. And then drop in the new platform dx and platform dy variables. Oh yeah, this is going to be great. Run the project and wait for it. Oh yes, look at that. Doesn't that look great? We are being carried along beautifully by the platform. No obvious pixel slippage, and we can even walk left and right as we travel along. One thing we haven't implemented here is continuation of velocity. You will find that as we jump off the platform, we jump vertically upwards and are not travelling along with the platform any longer, but perhaps that is one for another time. Maybe slightly surprisingly, you can see that when standing in the path of this platform, we even get pushed along by it. That is because as soon as we collide, the platform is counting us as being on the platform and moving us with the platform. But this may be a bit finicky and prone to issues. Here, let me show you. I'll click into the level sprite and add a solid wall right in the path of the moving platform. So what do you think will happen now as I travel along on the platform? Here we go. Oh! Now, I was not pressing jump there in case you didn't understand what you were seeing. What is happening here is that when a platform moves us into a collision, we still have the fix collision in direction script running, and that attempts to lift us up out of a collision. But in this case, the collision cannot be resolved by moving us up. No, we need to move right to get out of this one. As such, we bounce upwards, and things do not look so good. So can we just set the fix collision in direction to 90 to push us out sideways? Let's give it a go. Wow. Yes, okay, so that's a lot better. So why did we set it to 0 in the first place? Well, because we were originally dealing with an up and down moving platform. Click back into the platform sprite and switch back the old animate platform script, the ones that make the platform move up and down. Now let's see if this platform is still behaving itself. Oh, what? No! As soon as I was on the platform and it moved, I was wriggled right off without warning. This mechanic has been completely broken by the change to fix collision in direction to 90. So just confirm that, let's go back to the player sprite and change fix collision back to 0. Yeah, look at that. We have perfect movement once again. But that means we have a problem. And the root of it is simply that the fixed collision in direction is not suited to getting us out of an unknown direction of collision. Find the fixed collision in direction script. And I'm going to move it into some free space. Now, just to refresh your memory, I've removed the run without screen refresh from this custom block for the moment. So if I place Scratchcat so that he's colliding with the level, like so, and then run the fixed collision in direction 0 script, you can see him bounce up and down further and further until he is safely out of the ground. But if we change the direction to be 90, then the cat is instead shaken left and right more and more until they find themselves out of the ground. But the problem is this. What if the way out of the collision is neither to the left nor up, but perhaps diagonal? What we really want is a fix-up script that can find the closest point we can move to that is not colliding with the level. So rather than searching back and forth like before, a better solution may be to search in ever-increasing circles, looking for the first point that no longer collides. Sounds perfect. How hard can it be? Make a new custom block, naming it Find Closest Space to, with a numeric input of X and another of Y. That will be the middle of our search circle. Then add a label max and a numeric input of the same name, max. This will be the maximum distance we look for a way out of the collision. Then finally, we most definitely run without screen refresh. Let's duplicate this fix collision in direction script, as that will be relatively similar. Just separate off the repeat loop. Okay, yes, we want to record the original direction so we can point back to it once we're finished. And yes, we want to begin looking just 1 pixel away and then work our way outwards. But this point in direction, just throw away the dir parameter, as this custom block doesn't have one of those anyway. What I suggest is that we set it to 0. We begin looking directly upwards. Okay, cool, we're set up. So actually put back the repeat loop. We'll use the max input variable as the number of times we will repeat around. Now, remove the scripts from within the repeat loop, but keep them handy. The first loop is repeating to move us on ever-increasing circles. We'll need a second nested repeat loop to actually move around in a circle, testing for collisions. We need a compromise here, though, to avoid doing too many checks, and I've chosen 16 points per circle. We ensure we always begin at the same point with a goto x, y, and drop in the input variables x and y. Then, since we are already facing the desired direction, we move forward by distance. So, having moved, are we touching anything solid? Bring back the check touching solid and its connected if script. If we are not touching solid, then this restores the direction of the player and stops the script. We would be done. Super! But if not, then we need to search on. So right after the if check, turn the player clockwise. But by how much? Well, 22.5 degrees actually. How did we come to that number? Simple. 360 degrees is a full circle, right? And we are repeating 16 times. So 360 divided into 16 parts is, 22.5. Great. And so after a full circle has been searched, we need to grow the size of our circle's radius. Change distance by 1. Do make sure this is not within the repeat 16, but is within the repeat max. Stonking! All that's left is to restore the original position, if we didn't find a way out of this collision. Go back to the original position, using a go to xy with the input of x and y. And we stored the original direction in the variable orig. So, point in direction orig. So, we are facing the right way. Here, let me size it into view. So this is our find closest space script. Excellent. But come on, let's see it in action. I'll position the cat with his feet colliding with the floor, and then click the new find closest block. Bam! We appear back on the surface. We can test the wall to our side too. And wham! We move out of the wall to our left. That is super. But what about the tricky one? Overlapping both on the bottom and the side. Oh yeah, we get moved diagonally out of the collision. That is awesome. Shall we see it slowed down? Edit the custom block and disable the run without screen refresh temporarily. And here we go. Now, I've sped this up a tad, but can you see how we are moving in circles that are getting bigger and bigger until, pop, we've found a point of no collision. It should be noted that usually the amount of overlap is quite small, and so the number of checks required are far less than we are seeing here. Great! So this clever script is the real magic that solves all of our platforming woes. It's our get out of jail free card and will simply make everything work. So what are we waiting for? Let's get it in the game. Okay, so don't forget to re-enable the run without screen refresh if you unticked it. Click into the player sprite and find with me the define moved by moving platform. We are going to remove the old fix collision in direction script, and in its place we use the new find closest space to block. The position is going to be the X position and the Y position. That's the current position of the player. And so what about the max distance to move? What's that about? Why would we want to limit this? So for now, stuff in 16, and we'll talk more about that in a second. It's about time we smashed the green flag and gave it a test because I am dead excited to see it work. Firstly, jumping on the simple up and down platform. Oh yeah, that is working just as well as it did before, which is great news. But stop right there. What do we want to happen if we are standing right here? Will we squish through the wall, be pushed through the lift, or moved out of the way? What do you think? Okay, enough of that. Let's find out. Right. It pushed me back to the left out of the way. Let's try this again, but right underneath now. Pop! It pushed us out the right-hand side. What if we were under the lift? Just the edge to start with? Oh well, that was okay. But how about right in the middle? This isn't going to be pretty. Hold your breath. Oh, boom! There you go, poor Scratch Cat. So you remember that number 16 we put in the max value in the find closest space to block? That was saying that when we collide, the furthest we can be moved to safety is 16 pixels. Well, when in the centre of this lift, there is no safe move within 16 pixels of us. So boom, game over. Before we think more about that, Let's try out a horizontal moving platform. Click into the platform sprite and switch around the scripts again. And let's see. Jump on the platform, and then when we hit the wall, yeah, perfect. We are simply pushed back out of the wall and fall down gracefully. Oh bother. Oh, let me try that again. Oh, whoops. Oh, it's okay. I got this. And there we go. Yep. And I should be able to be pushed along. Cool. This is looking really spot on. Good. Then we should revisit Scratch Cat's demise. Yes, sorry Scratchy. Get back under that lift and we'll work out what's to be done with you. Now, as soon as our find closest space fails to find a free spot within 16 pixels, what we want to do is, well, sorry to say this, but that's game over, kitty. Or at least we lose a life, right? And we can tell when this occurred by using an if and checking for when touching is still greater than 0. Then, thank goodness we covered losing a life in the last episode, because now we can simply broadcast lose life. Run the project and check that out. Okay, here we go. Don't panic, Scratchy. It's okay. Oh! Not so okay, but thank goodness cats have 9 lives. Another go? Super! So, how close to the edge can I get away with? Ooh, that was about it, I'm guessing. If you want things to be more strict, then you'll have to try using a number less than 16 in your find free space block. But brilliant! We are almost done. I'm just going to finish by trying out a few more platform movement patterns. Click into the platform sprite. So first off, don't think you are limited to horizontal or vertical movement only, or even just back and forward motion. Look, we can add in a third position with differing speeds. Let's give that a ride. I'm going to have to jump over. Oh bother. Okay, so that's perhaps something to watch out for. If we move off screen, then the platforms all reset their movements. Now, we could address that by keeping each platform as a sprite or clone and never stop or start it, just hide it when it's not in the current scene. Or design your level to stop you moving off the screen so easily, perhaps, like having a roof. I'm just going to remove the obstacle for now so you can see it moving around me. There. So cool. But what else can we do? Let's run over to scene 3. I'm going to add a vertical sliding heavy door in here. Scroll to the when I receive change scene. We can duplicate this if checking now for a scene of 3. If we run that, then we'll end up with the same moving platform living on this scene too. But what I want to do is flip this around and use it as a moving door. So delete the second animate block, and we can create a new custom block named animate2. Remember, we don't tick the run without screen refresh. We're animating here. Make use of it in the new if. Gosh, my scripting area is getting a bit messy. I'm sorry about that. I'll just tidy this up and put together another vertical script like this. You'll need to play with the values to fit these to your level. But just let your imagination go wild, because you could make any shape move around that you could think of. What could you do with this, right? I bet you could think of some super ideas. I just can't wait to see them in this week's studio. There, that's cool. Oh no, I forgot to reset the rotation of the normal moving platforms. Hold on. And there we go. We are off. And with that, my dear fellow Scratchers, we come to the end of another episode. But what an episode! I hope you have learned a bunch of helpful stuff in this one. So please don't forget to smash that like button, and if you haven't already, then subscribe to the channel right now. Who knows what day a video might pop into the notification area, and you don't want to be late to the party. Next week I'm going to be mixing it up with something completely different, so watch out for that. But by no means are we 100% done with this series yet either. I just want to thank all my channel members for their ongoing support, and if you are a loyal fan or an educator who uses my teaching, then please do consider joining the membership too. There's some great perks to be had, plus it helps me to be able to make even more videos. Win-win! But until next time, thanks for watching, and have a great week ahead. Scratch on, guys!